Okay, this video is about trigonometry. I recently put a video up which was a animation that I'd made on Desmos, and probably it didn't make sense to a lot of people, so in this video I'm going to be explaining it a bit. Let's just start off with the basics of trig, which is what all of the trig functions mean, right? So the sine of theta is the opposite divided by the hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is the opposite divided by the adjacent. Cosecant is the hypotenuse divided by the opposite. Secant is the hypotenuse over the adjacent. And cotangent is the adjacent over the opposite. Okay, so let's notice some things. You can see that cosecant here is the flipped version of this. And if you flip this side, you also flip this side. So this is sine of theta over 1. So it'd be 1 over sine of theta. So we get cosecant of theta equals 1 divided by the sine of theta. We can do the exact same for secant, but with cosine this time. This is the flipped version of this. So we flip this side. And we get secant of theta equals 1 over cosine of theta. Okay, you can do the same for cotangent, but we're not going to be using that today, but just know you could. Another important one is that sine of the angle over the cosine of the angle equals the tangent. I can show you why quickly. It's because sine is the opposite over the hypotenuse. When you divide it by cosine, that's the adjacent over the hypotenuse. And when you divide fractions, you flip and then multiply. So we have opposite over the hypotenuse. You flip this and multiply it. Hypotenuse over adjacent. These two cancel and you get opposite over adjacent, which is our tangent. So that means that the sine of theta over the cosine of theta equals the tangent of theta. Okay, that should be all of the identities we need now. Let's have a look at a diagram that kind of explains why, when you graph these functions, tan of x, sine of x, cosine of x, why they look like they do. Let's just start by drawing the unit circle. So that's the circle with radius 1, right? Now, our sine was the opposite over the hypotenuse, right? So sine of theta is the angle theta equals opposite over hypotenuse. Now in this case the hypotenuse is 1, right? Which means sine of theta equals the opposite. So here's the opposite, we can label this sine of theta. Exact same thing for cosine. Cosine equals the adjacent over the hypotenuse, right? So A over H. H is 1, so cosine equals the adjacent. Just like that. Okay, now we're going to find the tangent. So let's draw a line right here that's perpendicular to the radius. Now this angle here is 90 minus theta. You can see that because they have to add up to 180, right? So in this big triangle we've got theta, 90 and 90 minus theta. Okay? In this smaller triangle we've got theta, 90, and this would be 90 minus theta. So these two triangles are similar. So if we call this distance d, d over 1, opposite to theta over adjacent to theta, will equal opposite of theta over adjacent to theta. So d over 1 equals sine over cosine and d over 1 is just d, and sine over cosine, like we saw before, is the tangent. So this is the tangent of theta. Okay. Let's have a look at this line. Now, I actually forgot to show you this, but cotangent equals cosine over sine, and we know that because cosine over sine is adjacent over hypotenuse over opposite over hypotenuse. You flip and times, so you get adjacent over hypotenuse times hypotenuse over opposite. Those cancel, that's cotangent, adjacent over opposite. Let's draw a line here, and let's call it L. Okay, this is 90 minus theta, because this whole thing is a right angle. This is a right angle, so this must be theta, because they add up to 180, right? So, notice that L is the adjacent to theta, and 1 is the opposite. So L over 1 equals adjacent to theta over opposite of theta. Adjacent of theta is also cosine of theta over, and that's being divided by the opposite, so sine of theta. So L over 1 equals cosine over sine. And like we just said, that is all going to equal cotangent. So L is cotangent of theta. Okay, only 2 more to go now. Let's look at this line here, okay? So this is the hypotenuse of theta. Let's just call it x. X over 1 is the hypotenuse, right, this line, over the opposite 1. That's also going to be 1 over sine. And like we said before when we were looking at the identities, 1 over sine is cosecant. Cosecant of theta. And our last one is if we look at this line here, so this line, let's call it n. N is the hypotenuse to theta. N over 1 is hypotenuse over adjacent, which is also going to equal 1 over cosine. And 1 over cosine is secant of theta. And that's every trig function. And you can draw so many identities, like I'll give you an example. The tangent of theta squared plus 1 will equal the secant of theta squared. That's just an example. Cosine of theta squared plus sine of theta squared always equals 1, right? Pythagoras. So I think this is just a really good way to understand trig. And if you go back to my previous video, there's an animation of all of these lengths moving with a change to the angle. So, and also there's all the functions that I used to make it, so go check that out if you haven't already. And yeah.